Okay, uh, I report to you the progress of my mm, in trigonometry. And first I explain how to compute length between 2 points in xy coordinate. So I made little things over here. Now here's a Pythagoras theorem, and that explain how we made this up, but I explain and draw it. So we make a line. Let's make it over here, and then we make 2 points from this one and this one. There's a 2 point between the lines. It's over there and over there. There is let's call it x1 point y1, and then we draw, and there is another, which one is x2 point y2. So let's make this, oh, not good one. Let's make good one. Let's make it over here. So we make this, it's over there at that point. So there is a triangle which are right triangle, because we imagine that it is a right triangle, and we can draw it like that. So we can use the Pythagoras theorem, and this is how we used. We find this C. Let's draw a C. What I meant, C as a hypotenuse of A and B. So what these A and B are in these coordinates, there will be A as xy, x2, sorry, this x2 minus x1, x2 minus x1. Okay, why they are like that? Because they are pointed from over here. Let's make it that as a 1 and that as a minus 2. So this become as a, let's put it over there, 1 and minus 2. So we get the coordinate 3. Ooh. So it's 3.1. And then as a y2 over here. No, it's just G something. And let it make that is a 1 and point it to 3 minus 3. So there becomes minus 2. But when we make it to power 2, it makes 4, no matter is it negative or positive. So that's why there became and point is, this is a 9 plus 4 to square root. Is the square root? Something like that. So this became 13, and there is an answer to this C. So the C is 13. Square 13. So, quite easy. Let's make to another. Don't say. Okay, then we do the unit circle. So I made a question from how the change decreased to radians and radians to degrees. For now, I explain what is the degree. Degree is oh, we know what is the degree, but we don't know what is the radius. Radius is became from this formula how we explain the circle, and the radius is over here, but when it's unit circle the radius is a 1. So when the whole circle is 360 degree, the whole circle in radius is 2p from this formula. Okay, so when the change is 360 degree is 2p, we can do maths and calculate that 180 is a 1p. So the 1 degree is a p divided 180, and the 1 radius is 180 degree divided by b. So the a, what is over here now, I assume that it's a 40 degree. So in radius it is, by this formula, is 40 what is it called? Anyway, 40p divided by 180p, so 2p 90 divided 9. So that is a radius for A. Okay, let's go to another. Don't save. Okay, so we don't know the point. That was the third question. How to compute coordinate points in a circle when the middle point, the radius, and the angle is known. Okay, so I made random middle point called GF, and the radius is also could be unknown, could be random. So let's point it R, and the angle is A, and the angle is over there, which coordinates these points. So we know this length by Pythagoras, what I explained earlier. So we could have x and y by hypotenuse and the a. So there is a memory, what do you call memory rule for that. So the sin is opposite divided by hypotenuse, and the cosine is how is it? Adjected. Anyway, divided by hypotenuse, and the tangent is opposite divided by adjective. So adjacent adjacent. Okay, so we can translate this as we know the radius and we know the angle. By this formula we know what is the y, and y is a sin of a no, multiply with r, and so on. We can find an x, also this formula, excuse me. Okay, so we can manage this, find x by cosine of a and multiply with r over here. So we can find the x, y by this. Okay, we can find the x and y by this formula over here. So the g plus g we can find over here. G plus cosine a dot r, and we can find f nu y over here by f plus sin a multiply with r. Okay, that was it. Thank you.